we ask a lot of questions about like, okay, so this animal lives in a freezing cold environment that's dark all the time. Oh, and there's no oxygen, but they're swimming around and living just fine. And it's like, okay, how?
Welcome to the Audiotocracy Podcast,
where we sit down with makers, purveyors, entrepreneurs, and innovators
who have stories to tell and passion to share.
This podcast is brought to you by Audiotocracy Podcast Production,
a boutique audio shop that supports clients to realize their podcasting dreams, like us. Need a podcast to voice your value?
Find us at audiotocracy.com.
That's
AUDIOTOCRACY.com.
Audiotocracy.com.
Hello and welcome everybody. I'm Rachel Miller Howard. I'm the creative director at Audiotocracy. And today I have the immense pleasure of sharing a conversation I had with Dr. Annie Lindgren, who's the director of the Portland State University Center for Life in Extreme Environments, which is probably the most interesting job title out there. Dr. Lindgren is a deep-sea biologist, and she studies some of the wildest animals on the planet, like squid, octopus, anglerfish, even a creature called a vampire squid that isn't actually a squid or a vampire. Intrigued? Let's dive in.
I'm a deep sea biologist. I study squid and octopus, and I grew up in the desert as a kid, obsessed with the ocean. I've done research all over the world. Most recently, though, my research is actually not very far from here. So it doesn't take very far to leave the coast of Oregon to get to a really amazing, dynamic, deep sea environment. So for me, I take the lovely road trip down to Newport and get on a research boat there. And we only have to go out about 45 to 50 miles offshore. And our continental shelf drops off and we are dumped in water that's 3,000 meters, so over 10,000 feet deep. And that's where all the really cool animals I study live. They're not far away at all, right? They're closer right now than driving to Seattle. So it's really fantastic to think about standing on the coast of Oregon. Like you're really only 40 to 50 miles away out. And then, you got to go down in the water a little bit, but from things like anglerfish and viperfish and deep sea squid and octopus of all kinds. So that has been the most fun work that I've been doing the last couple of years because it's so local, but also it's like another planet.
And so how do you get to these places? Like you go out on this boat, but then what technology is actually dropping into the water to study these places that presumably at some point become too deep for humans, for our bodies to go?
Yep, exactly. No, that's a really good point. So, I'm scuba certified and it does me no good for my research because, these animals all live at pressures that would kill me, squish me like a grape in a matter of seconds. So we go out on these research vessels that are fitted with these really large cranes and frames that allow us to drop these very specialized nets into the sort of deep water. So the animals that I study live at around 600 to 800 meters. So it takes, about an hour to deploy the net that deep. I mean, it's really like if you were to blindfold yourself and stick your hand in a black box, having no idea what you were going to pull up and then pulling stuff up. And every time we find new things. So, the technology that we use is actually pretty simple. It's like a big fishing net. Honestly, the end of it has a specialized metal box. So all the soft-bodied animals go in through the net and then they get in this protected box so that when we actually pull them out, they're not completely destroyed. They don't survive the trip up because the change in pressure for them is so great. But the bodies of the animals and the potential for the scientific discovery that they have is very, very high, because the technologies we use in terms of collecting them is actually pretty awesome.
And so you dip the net down, and there's no way to target a particular species. You're just sort of like dropping it in, like, we'll see what we pull up.
Yeah, a lot of it is that. A lot of deep sea biology is, we know so little about so much of the deep ocean that it's always kind of like, we'll try to get the thing we're interested in, but we'll see what we discover. We do have a fair bit of data based on historical sampling, and also places like Monterey Bay and NOAA that have all this amazing remote operated vehicle technology. So, they deploy underwater robots with amazing camera systems to document where different animals are living at different times of day. So we have some good baseline information of, if I want to collect, one of my favorite animals is called the vampire squid. It's not a vampire or a squid, but it's a really cool deep sea cephalopod. We generally know where it should live, so we can deploy the nets to the correct depth. And it's pretty cool, actually. I swore when I was in high school, I would never use trigonometry for anything as an adult. And that's how we figure out the angle of the net to figure out what depth to deploy it to, is using simple trigonometry. So I feel like I need to send my whatever grade math teacher an apology email. But so, we do have some information, but even with that, we're never far away from discovering a new thing when we collect animals from the deep sea.
Yeah, so what percentage of those deep sea creatures do we know about? Like, how much mystery remains?
Ooh, well, I'd have to check the most recent metrics, because we do have a lot more ROV sort of research happening. But, we've sampled, like, in some way or another, studied way less than 10% of so I consider the deep ocean to be anything that's out of the sunlight zone, where plants can photosynthesize and create new energy. So the deep sea starts at about 200 meters. So there's no more light. Everything living there is reliant on dead things falling from above, or, some localized like chemosynthetic activity in the very deep ocean. So the deep sea itself is huge. It encompasses like over 80% of the ocean. That all to say, the amount that we have studied at all as humans is like 2% below that 200-meter depth. So everything is new all the time. And it holds such amazing insight into the rest of the living environment that, I don't know, it's just, everything is always new. There's like, it's never a boring day. You're either finding a new animal, or, we ask a lot of questions about, like, okay, so this animal lives in a freezing cold environment that's dark all the time. Oh, and there's no oxygen, but they're swimming around and living just fine. And it's like, okay, how? And so, it's just ripe for discovery. I mean, it's very low hanging fruit in terms of finding something new and cool all the time.
Yeah, that's such a good way of putting it. And so, besides the obvious just fascination factor, why is it important for humans to be studying these environments and these creatures? Do we have skin in the game as humans?
Yeah, that's a fantastic question, and something I think about a lot, right? Scientific discovery for its own sake is huge. But when you can take scientific discovery and apply it to something that is, a critical environmental concern, or a potential human concern, from, climate change to food security, it does take on a different level of urgency. And so I can just give you an example. 50% of the oxygen that we breathe every day is made in the ocean. And we know that oxygen levels are decreasing a little bit in the ocean because of, things like increasing ocean temperatures releases oxygen out of the water. And so there's a lot of animals that live in the ocean So things like tuna that we care about very much for eating needs a high oxygen level or it can't survive. Now, there's a whole suite of animals that live in the ocean in specialized pockets of water that don't have oxygen or have very little. And so I really struggle as a scientist watching the environment change and what does it mean for conservation? And something that I really appreciate a lot of the work in CLE for is its sort of proactive preparation and planning almost. So a lot of these animals living in extreme environments that we study most likely hold the key to kind of, I would say, evolutionary novelties that will help us better understand how other animals will respond as our environments get more extreme. So there's sort of like I'm not saying Earth is going to not have oxygen on it, but if oxygen levels do drop in specific parts of the ocean, what's that going to mean for the fish we like to eat or corals that we care about? And so we can look to these animals living in extreme conditions, understand how and why they're able to thrive, and then take that knowledge and apply it to more proactive management and conservation of species that really do significantly impact humans. And it's just one more kind of cool side story on the oxygen front. And we think about, a vertebrate animal like a fish living in the ocean without oxygen. It doesn't take that many steps to tie that to how we help humans who are undergoing oxygen deprivation, right? So we actually have a researcher here who is working on collaboration with a doctor that oversees hyperbaric chambers for people. So it doesn't take very far to get from some weird fish that doesn't have any oxygen in its environment to how do we help people heal from oxygen deprivation. So that was kind of a long-winded way of saying there's a lot of ways that just studying these crazy animals can provide a lot of information about human survival and along a wide array of avenues.
This might be kind of a far-fetched question, but when you're looking at these unusual creatures, do you ever feel a sense of inspiration? They've been able to adapt to this wild, wacky environment to survive. Is there an extrapolation of that I could implement in my own life?
100%. And we only ask wacky questions here. So that's a great one. Yes, that's kind of what we're trying to do every day. It's how is this animal living here? Okay, well, so it turns out a lot of what it does is when oxygen levels are low, it just stays really quiet. It doesn't run around. It, doesn't feed a lot. It just sort of goes into kind of I'm going to just snuggle in bed and watch Netflix all weekend mode. And so, there's some really interesting, simple behavioral adaptations that are totally applicable, I think. Yeah. So, I don't know. I think these little guys have done so much of the hard work for us. We just have to kind of listen to them.
I love that. Taking cues from creatures in the most unusual and extreme environments. Yeah, it seems like there's something very useful and instructive for us there.
Absolutely.
Okay, so you mentioned the vampire squid. Mm-hmm. Is there, maybe it's that one or maybe it's another creature, but which one do you identify yourself most with?
Oh, that's a really good question. I have to say the vampire squid, so its name is Vampiroteuthis infernalis. It's like this weird ancestral relative of both, it kind of became its own species before squid or octopus even decided that they were really things in the world. And it's this amazing animal that there's one species across the entire globe. It's really slow moving. It's about the size of a softball, although the ones we have off the coast of Oregon can be like the size of a toaster. And I just am completely fascinated with how this slow moving, super quiescent animal has just sort of been all over the entire world in the deep ocean and stayed one species and really just survived. I mean, it's one of the only, or it is the only cephalopod that eats dead organic matter. It's got these like little filamentous tentacles that it kind of waves around and collects whatever dead stuff is floating in the water, and then it licks it off. And sometimes it will hunt if there's prey around, but it's fine. I think given that I'm a super busy, probably more type A than I'd like to be person, I definitely aspire to be Vampiroteuthis. Do I achieve that goal? Probably not. But it's a fascinating animal. And we know so little about it that I definitely am intrigued. The first time I found one off the coast here, I couldn't believe that I had caught one. I didn't expect to find them off our coast very often because there are very few records. So I had pictures and I knew what it was, but I still sent, I have a wonderful mentor and colleague at the Smithsonian who he's made it his unofficial life's goal. He supports women in science in a way that is just astounding. Anyway, I sent him pictures and I said, this is really this, right? And he was like, yeah, I don't know why you're asking me. You know that. Because I don't believe my eyes. But anyway, I think seeing one in real life, just coming up from the deep ocean, was one of the coolest things that I've gotten to experience as a deep sea biologist. And I had 8 undergrads with me when we found it, and watching them experience that was like triply cool.
Yeah, that's so special to have that treasured moment and then have younger people there. So, okay, so you grew up in the desert. Mm-hmm. And you were obsessed with the ocean. Mm-hmm. How can you just sort of explain how you got from desert to ocean?
I think it was a series of just lucky steps, to be honest, a little bit. So I did grow up in New Mexico in the desert. I really wanted to go to the University of Washington for my undergraduate because the UW had a great oceanography program, but I got a free ride to stay in state and go to school in New Mexico. So I accepted my desert fate. But when I got to New Mexico State, which is where I did my undergrad, I met an amazing professor who had just started, and she studied these little squid that live in coastal waters, mostly in Hawaii, but other places in the world too. And so it was kind of serendipity. And I just bugged her until she let me work in her lab. I started as like a undergrad making seawater in the desert and taking care of these animals. And then I started doing my own research with her. And I stayed on with her actually to do a master's because I was really excited about what I was doing. And then from there, I went and did my PhD, also not near an ocean at Ohio State, but I worked with another fantastic woman who was she studied sea anemones and how they've evolved in the oceans. So a lot of finding amazing women to work with and never actually being by the ocean. So I tell all my students, you can easily be a marine biologist, not ever having been by the ocean. It's easier, but it does make field work awesome. Right? When I was a grad student, I got to go to France. I went to Australia. I went collecting all over the place. So, you just go find the ocean if you're not by it.
Right. It almost seems like, in a sense, there's more opportunity if you're not by the ocean, because then you can be dispatched kind of anywhere.
Yeah.
Versus if it's conveniently in your backyard, then it's like, well, I guess that's sort of the easiest path of least resistance to just go to the one next door.
Right. That's a super good point. Yeah. I mean, would I have studied animals that lived in so many different places if I could have just gone out and collected them 100 feet from where I was working? Probably not. So yeah. I mean, the other great thing about being a marine person is the amount of material that's been collected by scientists and stored in natural history museums means that there's just, tens and sometimes hundreds of years of knowledge that you can access just by going to the Smithsonian or other places. So I spent a lot of time not at the ocean per se, but in old collections and jars full of pickled animals looking at cool things as well. So lots of ways to be a marine scientist for sure.
Yeah, so I'm curious is there a big gender discrepancy among marine biologists and oceanographers?
I think there are a lot of women in our field. I would say it's more balanced than others. It's interesting in the natural sciences, there have been over the time that I've been in this field, more women coming into it. I think it's still very challenging for women. There is a lot of sexism that we experience being on research boats. It's gotten much better, I will say. Field work can be dangerous sometimes for women in various places, but the network of amazing female scientists and men who work with us all has grown into a really, a pretty awesome thing, at least in my network.
Yeah. Yeah, that's cool to hear. Hearing you talk, there almost is like something very poetic, for lack of a better word, about these environments and this kind of work. Like, does it feel like there is an element of artistry when you are conducting this work and going out into these unique places and then sort of seeing and assessing who's out there?
Absolutely. My father's an artist. My mother, her first career was as a costume designer for operas around the world. And so I bring a lot of love of art to my science. But I also think that art in any form plays such a critical role in interpreting and understanding scientific novelty. And you can't look at some of these animals and not think of them as works of art either. So, for example, we found an anglerfish, which was one of the other, that and the vampire squid were my two favorite things I've ever caught myself. But this anglerfish is the darkest pigment that exists. It's not even something that can really be recreated by humans. And just looking at this black pigment was just fascinating. So, I think the animals themselves are art. How they interact is like this amazing dance. There's so much potential for poetry. My husband is a huge heavy metal fan, and he thinks it's hilarious how often our worlds intersect, especially if you try to Google like deep sea something on, say, YouTube. Half the time I get heavy metal music videos. I don't get like science. So it's just super interconnected, at least in my world. It makes it more fun to sort of really tie. And also it's more applicable and understandable to students who maybe don't think they're scientists, but they really are. So it's a great way to engage with folks that feel like science is unattainable to them.
Yeah, that's so wonderful. I love hearing that. It was also making me wonder if there's any sort of kinship between oceanographers and astronomers. Because, right, it just kind of feels like there's a link in the level of mystery and the fascination and the sort of artful science that backs both of them.
Yeah, absolutely. The overlap is actually quite strong. We actually have an astrophysicist in CLE, and she designs microscopes to withstand space travel to go and try and detect life elsewhere. Turns out that using weird microbes that live in super extreme environments is a great test model for her microscope, right? So you just take different extremes and mash them together, but a lot of the sort of off-Earth science overlaps really significantly with deep sea and other extreme biology. Yeah, so we've got lots of folks here that have NASA grants to kind of build those bridges across from, the deep sea to the far reaches of space.
Oh my gosh, it's so cool. It's so, just so juicy and intriguing. What is next for you in your research? Can you give us any sort of previews for upcoming stuff?
Yeah, so a lot of my sort of long-term career work has been really trying to understand how different groups of squid and octopus have evolved. So we continue to work on that. The advent of new, better genomic, more data has really allowed us to gain better information to generate stronger hypotheses about how animals are related. So, we'll be publishing a paper on that using this really cool, another weird, just like this one kind of squid that's not related to anything else. And we managed to get some really good genomic data for it. So we'll be publishing that. But also I continue to do a lot of the work on the deep sea animals living off the coast of Oregon. So we've just started to, I'll say it one more time, but the advent of all of this sort of genomics technology where, you can take an animal from the deep environment and flash freeze it, and then you can study its proteins, you can study its metabolism, you can study the exact genes that it was expressing at the moment it was preserved. So we can build a whole information database about how this animal's body was functioning in the deep sea and start to really uncover all of those sort of genetic novelties that allow it to survive in that extreme environment. And then, start to look for those genes in other animals that live, in changing environments on Earth. So we're using a lot of those deep sea animals off the coast of Oregon to start asking really cool questions about how, what are the underlying survival, what's the toolkit look like if you're a deep sea animal living off the coast of Oregon. So that is all new to me, honestly, the technology and how we do the data analysis. So it's kind of fun. I feel like I'm a grad student again, getting to do all new research. But it's very cool and fun. So yeah, and I hope to, not this summer because it's still tricky with where we are in the world, but next summer I'm really hoping to take another cohort of undergrads out to sea again. So fingers crossed, we'll make that happen.
So cool. Well, thank you so much for shedding some light on this otherwise lightless area. Truly, yeah, it's just so fascinating to learn from you. And yeah, thanks for taking the time.
Yeah, I'm always happy to talk about this stuff. It's fun to get to nerd out on it any chance I get.
So many thanks to Dr. Lindgren for taking us on a tour of the deep sea. To learn more about her and her work, visit pdx.edu/extreme-environments. And if you're interested in exploring a podcast for your business, organization, or research, visit audiotocracy.com to schedule a free consultation. See you next time.